Start. Okay, the recording started obviously. Uh, Welcome, Friday. Happy Friday. So let me first show you a little bit in not OneNote, Brightspace. So under our course, I uploaded few things. Okay, let's just introduce them as well as let me show you where the video lectures are. um, I don't know if the auto caption is not working. Let me know. I'll try to fix something in case if you need the caption. If you don't, then you just can see the video lecture if you need it. Okay, somewhere if you can miss the class. Is the video lecture is working for all of you? Did anyone of you try here video lectures? No. Uh, okay, if you miss the class, then it could be really helpful. In other cases, maybe also class notes, very important thing. Okay, whatever, because of the OneNote issue, obviously you don't have the access of the OneNote. Whatever I'm doing it here, like the problem was the soft copy is here. Okay, as an example, say like this is what we have done so far, right? Remember, in my OneNote I started answering this question. You might have took the class note, right? So this is just for reference. All those things are here. We have done pretty much everything, this math, right? And this math, all those maths we did, right? So that is kind of like up to last class. And today's class, let me show it to you. This is the new material that I have here. I'll try to keep adding stuff here, okay, for reference. Now obviously you're not gonna see. Just one second, it's taking time to pull up. Okay, it will come at some point. Hopefully. Okay, problem with this thing is, okay, finally. So this is the new material for you guys. I'm gonna start writing stuff here on this material in OneNote, and you don't have the access of OneNote. That's why I have these materials here for you guys. Okay, for reference only. It might be helpful to you. I mean, basically, it does have the math problem. It has the explanation. As you can see, I keep going on. Now, obviously, for me to start writing the question for this math is not too fruitful with, way of using the class time. Okay, so I have the problem here. And it's not sometimes too fruitful for me to get a printout and give you the printout, as well as just, wasting of paper printing. Okay, but bottom line, you have the reference. You understand what I'm saying? So you just have to this time deal with the Brightspace all the time. Okay, for the video links of the class I just showed it to you, and the lectures for any of the class that I do, references should be here most of the time. If not, I wrote the problem that is different. Come back here. Just one second. So that's I tried to. Okay, so that is what I'm doing today. Week 3. Just one second. This is what I did already, right? Okay. So before I begin, I thought I had this separated. This is one of the things for sure, right? I'm gonna give you the hints for this homework number 1. How many of you are? How many of you are started this one? Um, Having issues or doing good? Some problems are kind of challenging. Some problems are very straightforward, like directly from class notes, right? You might have experienced that. But I have an intention to kind of talk about all the problems and try to give you as much as possible hint wise. Okay, so that's the main goal. Think this way. The other goal that I have, for some reason, is not showing. Um, yeah, just to finish these 2 pages. Okay, for some reason I don't have it empty here. But you know what, I can do one thing. I can create a page. I usually have this thing ready before the class start. I'm sorry. I'll make sure next time it is here so we don't have to waste time. So this is spring 2026. This type of thing I usually don't do here in class, so we can. So this is my week 2, right? So one second. Yep. So this is my material. I'm gonna just plug the material here inside as a printout. And now I should have it. All right, perfect. So two agenda, right? Obviously, the first agenda is do some theory here. Okay, we'll be doing the curvilinear motion. Previously, what kind of motion we did? Rectilinear. Rectilinear came from the name rectangle, like a straight line you're moving, right? No curve, nothing. So first of all, what's the motivation for learning this curvilinear motion? To have some examples here, right? Or applications, okay? During the class, please don't use the phone. That distract you. Uh, anyway, so you see here, you have these two examples. So first one, you're seeing a bunch of flights that just moving around, right? Obviously, it's moving in a curvilinear way. So if you'd like to know the velocity expression, positions, all sorts of things that we're doing for this curved motion and the example, you have to use different equations, not the one that you have used before, right? Okay, so that's always motivation. And the second one is a helical line track, whatever you want to say, for maybe like the roller coaster that you're seeing here. If you'd like to know like the motion, acceleration, velocity at any point, you have to use those kind of equations. Okay, enough motivation for you to learn this topic. We are still in the same chapter in case if you're reading through the book. Okay, and the book is still in the same chapter. Another topic after this one will be again in the same chapter, which is the relative motion that is in coming. Okay, on this one, on this focus. So now, obviously, in a curvilinear motion, okay, you have to deal with 3D, okay, and we won't be doing all the time 3D problems. Most of the time, we'll be doing 2D problems, okay. But let's start with the math with 3D. So when I'm saying the 3D X, Y, and Z, right? That's so obvious. So we'll be starting with this AX, AY, AZ, like BX, BY, BZ. You know B and A. Remember those? The acceleration velocity, right? So we'll be putting a subscript X, Y, and Z for all those parameters that we use, like the acceleration, velocity, and position. That part you understand, right? So far as what I said, really good. All right, perfect. So this part, that's the first part of this today's class. This part of my agenda is to introduce you with some of the equations, right? Not do any math here at all. Okay, possibly take 5-10 minutes, whatever it takes. The rest of the time would be just focusing on the homework. The way I'll be doing it, like I'll read through the problem. I'll try to give you some hints of the equations, okay, and some directions. Maybe that will gonna help you, okay, on the homework. Any question so far? It was good. Okay, perfect. Then let me start then. The pace is okay. Should I go a little slow on talking? Perfect. Okay, let me get my class note first. All right, is everybody ready? We have seen the slides already. Let me make it bigger. Okay. So obviously the application is on the right side. I'm going to start typing the equations here on the left side. Everybody want to take the class notes. Okay. So we'd like to do the review first. So when I'm saying the review, obviously, we have these two different equation, acceleration and derivative equation. Those are with respect to what? Time, right? Those two equations for sure. And I said like for curvilinear motion, you have this x, y, and z axis come in play, right? So obviously you gotta use this x direction, y direction, and z direction for these two velocities. So let me just start writing that. So x direction, y direction. I'm not sure if this call is so important. My son is calling. Is it okay just if I'm gonna hold it for a second? Yeah. Start that. It's a prank call from my daughter. Sorry about that. She's calling me. I don't know. Just my daughter is 5 years old. For reference, my son is 17 years old. It's quite a bit of different. Okay, so on the note, so x, y, and z direction, right? Everyone's with me so far? X, y, and z direction. Okay. X, y, and z direction. Y and then z. Keep doing that. All right, so you have these same equations that I'll be writing here, right? Ax, Ay, you might already understand, Az, right? And then all I'm doing here, just putting a subscript x, y, and z, right? Nothing else. So just writing the same equation. So like dv, and you already probably get the idea, right? You gotta put this subscript for all of them. dvy dt, dvz dt, right? And now, obviously, you want to write the velocity equation, right? So the velocity equation is dx dt, dy dt. I know you guys don't write the z this way. Let me write it your way. dz dt. Okay. In back home, we used to write z this way. Nobody writes z this way, right? Yeah. Okay. Anyway, so I'm gonna write your own way. Okay. So these three things, like ax, ay, and ax, ay, az, bx, by, and bz. We had this three definition so far. Everything known except this three direction came. Another thing we have used last time as well. So let me do that here. So we can rearrange things. So like for this one, okay, we can rearrange things and move like this acceleration to the right side, and we can write it. We can write it this way. See if you agree with me. All I did just move things, right? Move parameters, right? So can you do the same thing for the next one, which is ds over v equal dt? Can I do that? What do we have for equation 1 and 2? Both are dt equals something, right? So we can equate dt. So from equation 1 and 2, can we write this? Equation 1 and 2, can we write this? dv over a is equal ds over v. Can I do that? You can also write equal to dt. It doesn't really matter, right? But I'm going to take it out anyway, okay? So can we write the similar thing? Can we write the similar thing? I mean, you can do another steps just to make your life easier. So if this b dv a ds, can I write that? It's a little congested at the very end. Whatever I write the last line. I'm just moving things so far. Okay, nothing new. Okay, so now can I write this equation? If you'd like to name it as like equation number 3, can I write the same thing for these 3 different axes? Can I do that? Let me do one of them so you can finish the others, right? Say like I have this equation 3, okay? Equation 3, that can be written as vx dvx, right? Equal ax dx. Instead of s, I'm writing x, y, and z, right? So can you do the other two as well? And there is a reason behind all of these things that we are doing. Would be would be getting the equations for velocity and acceleration, but it is coming shortly. But for now, just focus on this, okay? Focus on these 3 different axes thing that I had so far. And again, the big term motivation here, the bigger picture here is like, obviously once you have the equation understood from these, you can possibly use them directly in your math problem, okay? So that's what you're doing, okay, in case you are wondering why you are even deriving something. Okay? Maybe the derivation is something that I won't be asking in your exam, but this is what you got to use, like not this one, it's exactly the final result equation in the math. All right, so obviously you can redo that. You can name it as equation number 3 again, similar way, and you can do that like vy dy, vy dby, right, equal what? Ay dx. Is agree? And you can finish that thought process by doing the z-axis thing, like vz dvz equal az dz. Can do that? All right, perfect. Okay, so then what do you want to do? I'm giving you some time to finish the writing. I mean, obviously seeing some of you are still writing is all right. Take your time. Oh yeah. Thank you. dy, right? All right. So everything's good so far, writing wise. So I said, like, you don't have to deal with 3D at all, like in analytical. But what's so important? I mean, in real case, you have to do 3D, right? And you would be using software, okay? So you need to know what is 3D and how it's working. But 2D case, you can do analytical for sure, right? Analytical means by doing math, and okay. So how would be dealing with 2D case, okay? Say like if you're dealing with 2D case, you can either use XY, YZ, or ZX. I mean, either way is fine, right? If you are focusing on XY, and then you'll be doing a particular case example, right? Let me do it for a projectile motion, which you have done. I know all of you in physics 1 lab, right? Projectile motion. Everybody remember projectile motion is going up and going down, right? Physics 1 lab. Everybody do that. So let's do that. Projectile motion. You'll be seeing in a homework often time that projectile motion problem is also there. So projectile motion is a 2D case. Why? When the projectile shoot in the air and come back to the ground, it's actually going in 3D, but in one direction it doesn't have any movement. So you can assume it's a 2D case, right? That's the case in a projectile when it's going up on the air, right? Acceleration wise, in x direction, it doesn't have any. I've seen it in physics class, right? So in other words, it's just moving up and then coming down, right? So when it's moving up at any position along the x direction, right? No ax. Acceleration we are talking. In the y direction, what is the acceleration when it's free moving? Is it gravity? So we have a gravity, right? And depending on the direction, you can say it's minus g going downward, right? You've seen it before. So let me write that. And again, this is just a quick sketch on the left side. Minus g. Everybody agree so far? All right. So then, if you're gonna use this equation and do the integration, differentiation, and everything, you would be coming up this with this equation: Vx equal V0x. So that's the initial velocity, if you assume when the projectile run, and this Vy and this Vy can be written as V0 minus GT. Now you can do the derivation, which I'm skipping completely, okay? We have done so many derivations already, first few classes, okay? But bottom line, from those equations that I had it over there, you can do the integration, come up with this velocity equation in x, y direction, okay? You guys are confident that you can do that, right? You just have to do the integration on those final form of that, right? Something like that. You understand? And it'll be coming up with that, which I won't be doing it here, by the way. I'm just not putting it over there. Later it may get confused, right? Any questions so far? Okay, so the other thing that you can obviously do from here is finding the position, okay? So the position would be in x and y directions. So these are the velocities. So the position would be in x and y direction, x0 plus v0 x t, and y equal y0 plus v0 y t minus g t squared divided by 2. All right. Once you have the velocity, then you can use it in the position equation to get this one. Not from those equations that I had derived before, okay? And again, it's the derivation, we're skipping that. We don't want to go through the derivation. You might have done it in physics class, right? Have you? In physics theory class, you should have. I'm assuming you might have done it, and depending on the instructor who is teaching, may or may not. This class agenda is not to derive all the time. Its agenda is to deal with the math, right? Real life math, okay? So time to time you see me, I'm avoiding some of the derivation. All right, so if you understand so far, I just would like to finish a few more things in next page of the slide, and then I'm gonna directly move to our main agenda, okay?
Is that gravity squared for that time
Now that's times square t. The t, anytime you see me writing something like that, plus sign is actually t. That's the way I write t. I know people write t like this way. How do you guys write? First way, second way? I know some people write it t this way. That's different way. People writing t. Okay. I always usually write it this way. Okay. So it's all t. Jason Tomer. All right. Any question? All right. So as I said, like, this is the next thing that I would like to cover. Unit vectors, right? We're dealing with 3D axis, x, y, z. Unit vectors, we have done it in statistics class last semester. Remember ij and k? ij and k ring a bell? Okay, let's do it. Let's do it. So you have this. These are review actually. So far, this unit vector thing. What I was talking. So you have this x, y, and z, and depending on your choice, you can put it literally anywhere. Now these unit vectors are obviously a small segment in this direction, I, j, and k. Now I don't know if you recall, you put a hat on the unit vector, right, on I, j, and k when you're dealing with the unit vector. So let's deal a little bit with the vector thing here. I, j, and k you have, right? And if you're gonna put it in matrix form, where you just have 1 row and 3 columns, right? So it's 1 0 0 0 1 0 0 0 1, right? X, y, and z. So let's deal with this. I mean, so far whatever I wrote, these are very straightforward. So 2D vector projection. So like, I mean, I'm not focusing on only 2D. Okay, as I said, most of the time I'll be doing that only. So you have this x and y, right? And you have this vector A, which is two-part. You can do the component of A, y, and x and y direction would be A, y, j, a, x, I. And then you have this A vector could be written as ax square, ay square. And this A can be written as axi, ayj. And in 3D, which is not too relevant for you here, is obviously axi, ayj, aj, k. Take your time. So like after 1 minute, I'll get started with the homework hints, okay? I don't want to go any further with the theory today. Next class agenda would be finish a little bit of the theory more and then do one math problem, okay? But we have quite a bit of agenda today. Try to finish the homework by this weekend. Upload it by Monday. After today's hints, it should be like so simple. I'll try to give you some questions as well. Okay? You should be trying to find those equations by yourself. That should be a goal. Let me know when you guys are done. All right. Done? Need some more time? All right. So let's deal with the homework hints. All right, we have quite a bit of problem. Okay, let's start with the first one. So it says here, what floor approximately must a car be dropped from an at-rest position so that it reaches a speed of 55 miles per hour or 80.7 feet per second just before it hits the ground. Okay, so the final speed is given as like 80.7, right? Is it clear to everyone? And they were asking what floor it was dropped. Okay, so like the car was dropped from a certain height. Okay, so like the top of the building, and so and the number of story is something unknown. It could be whatever number, right? So add number of story the building is, right? And then when it hits here somewhere at the bottom, they gave it the speed, the final position, right, which is 80.7 feet per second, right? There's the final speed. Now when it's dropping, the acceleration is what? Free fall, gravity. So it would be it's in English unit, right? Inch pound. So you remember it's not 9.8, it's 32.2. Sometimes people use 32. They don't care about this two, but 32.2 to be the exact value. Feet per second square, right? Now this g is negative a. If you it depends like which way your a you are assuming, right? A y, if it's going up, then it's negative. All right. So then the question would be like, how you can connect this acceleration and the velocity. Okay. Now, obviously, when it starts, what is the initial velocity? Zero is start from rest, right? That's what they said. Like, there's the keyword here. Yeah, at rest position when it starts, right? So you have this velocity. That's the final velocity. You have this v0 is 0, right? When it starts. And they said another thing here. They didn't say it's directly. They said it's free fall. Okay, no external force, nothing. So what happened with the acceleration in y direction? It's constant, right? It's the same value, 32.2. Do you guys remember like we did some derivation for constant acceleration when we had the relationship with velocity and acceleration? Should be looking at that. Okay, I could have given you the equation. Should I? I mean, I don't know. Maybe for the first one, let me give you the equation, but you explode it. Okay, where is the equation? So vz square plus 2a. I'm gonna put a acceleration, not the g. Okay, you gotta figure out what a would be because a has a relationship with g, right? In 1D, and that's just the 1D case, right? You can put a y as a subscript. That doesn't really matter because this is a 1D scenario. I need you understand the theory that I was explaining before. It's a 2D one, right? This is just 1D. For projectile, it's moving like this, right? So it has a 2D motion. But when the car drops from certain floor straight down, it's just 1D motion, right? One direction. It's not moving. And maybe you can say like the hurricane is coming, the car is moving a little bit far. It's not happening there. It's just moving without any interruption. All right. So is this enough for you guys to figure out what we are trying to figure out? Yeah, it's not direct. I mean, if I'm not going further, I'm giving you a direct answer. So take a look what we are trying to find. You are given with the final velocity. You know the initial velocity. You know the acceleration. What is unknown here? Huh? No. It isn't priceless. It will gonna be nowhere. You gotta be right.
The homework?
This is homework. This is homework things.
I'm talking about this, the homework on rice.
Oh yeah, definitely. Sorry, I got confused. This material, yeah, but this is on record. If you somehow missed anything, forgot to write anything or whatever, you can see the recording. Okay, but you understand what I'm saying? Brilliant. Tell me something. So you have the final velocity. You have the initial velocity. The acceleration you know, right? Is g. Yes. What is unknown in this equation? It will del y, right? Like y, but we just mentioned, yeah. So del y. Del y there isn't. They say del y is like the distance difference, right? Del y. You can say y. It doesn't matter. So y, right? What does it tell us? This y. If each floor is 12 feet, right? It's a standard floor height. Then if you have the total height, Then can you find how many floor it traveled? Yeah. So that's it. Brad, you are feeling confident with this one?
Yeah.
Perfect. We're gonna deal with all the math here slowly. And my honest hope from everyone that you would be doing it by yourself. Okay, not try to look for the solution manual. Just do yourself a favor. The second one, okay, on the second one, what we're trying to find. On the second one, it says here a test reveals that a normal driver, there's the comparison with normal and drunk driver, okay? So a normal driver it takes about 0.75 seconds, okay, to react to a situation to begin to avoid a collision. Means like this person that's sitting, actually not sitting, standing here, and you're driving car, you need to stop the car when the car is traveling at 30 miles per hour. So like in village, it's traveling 30 miles. That's the limit, right? And you need to stop. You're seeing suddenly somebody came, right? So the study suggests it takes 0.75 seconds for you to brake, okay, with some acceleration. Sorry, I should say acceleration, deceleration, right? When you're putting the brake, right, you can hard brake, soft brake, whatever, but whatever brake you put, the acceleration or the acceleration means the car has slowed down, right? The deceleration they give you like 2 feet per second square. Yeah, 2 feet per second square. Make sense so far? So your speed, initial speed, was given like 30 miles per hour, which is, by the way, 44 feet per second. You know the unit conversion, let's remember that from mile per hour, mile to feet, hour to second, right? So somehow you got it, right? So that was your speed, and your deceleration, the car slowed down at 2 feet per second square. That's, you can say it's A, but it's a negative value of A, right? Because it's deceleration. All right. So those are given, and 0.75 seconds. That you're just told like it takes 0.75 seconds for the car to stop at that rate, 2 feet per second square. You understand? Okay, that's the first scenario.
So
The second scenario,
oh, you do both.
yeah, you got
Okay.
both. The second scenario, so like there is a person who had some influence, okay, and the influence level is given as like 0.1%, okay, is it? Yeah, 0.1%. So if that's the case, it takes 3 seconds, okay, because of the shortness in the memory, okay, a little bit compromised with the influence. So it takes 3 seconds compared to person who doesn't have any influence from anything, okay? It takes 0.75 seconds. So two scenario, right? So you're doing the math. Now given with 2 different times, 0.75 and 0.75 is 3 seconds, right? So you're gonna find determine the shortest stopping distance D. Okay, what is this D? Do you see D here? Front of the car to the person, whoever standing. Okay, so that D you gotta find in 2 different cases. Okay, so you need some equations to deal with that. Now you're given with the acceleration, you're given with the velocity, right? You're given with the time as well. So the distance you gotta find. Is it clear? You guys started to see the relationship, right? Let me go to my class note, by the way. All right, let me see if I can help you with something. So you have a few things, like you have this velocity, okay, like the final velocity. You have this initial velocity. What would be the final velocity? When the car stops, what velocity are you expecting? 0, right? You don't want to run the pedestrian, so it should be 0. What is your initial velocity? It's like the 30 mile per hour, which is
44.
Yeah, it's given even 44, right? Feet per second. So you do have those 2 velocities, right? All right. What else? You have the acceleration, right? What is the acceleration value? It's 2, right? So should I put a negative before? It's a deceleration. You guys remember the deceleration? So negative must be there. It's feet per second square. All right. So from these, you can find the del S. Okay. You can find the del S. So this del S, whatever the value you're going to find, that's for, you see, there are 2 things here. So this del S does have this uh, that's not the total D. This del has does have this, so that's your del S. This del S does have this car travel, okay, with the deceleration. Okay, let me clarify. Probably I was not clear with that question before. See, if you're a normal person, if your 0.75 seconds means what? One, that much. 0.75, if you're a normal person, means like without any influence, you're in a normal situation. You see a pedestrian. Your brain needs to work such a way so you can press the brake, right? Does it make sense? So it takes 0.75 seconds. So before you are pressing the brake, it takes 0.75 seconds before you are touching pressing the brake, right? To get this acceleration. So question is, if the car is at the speed of like this, whatever speed it has, right, 30 miles per hour, within this 70.75 seconds, the car is gonna run still, right? So you gotta find that distance compared to a person who is in influence, okay? Before that person is pressing the brake under influence, it takes 3 seconds because he or she might be seeing bloody, okay, before think and finally pressing the pedal. By the time he or she does it, it takes 3 seconds already, right? So that means the car will not going to stop. It was running certain speed, 30 miles per hour or 44 feet per second, right? So you're going to run at constant speed for that 3 seconds. Does it make sense? Compared to where noise influence, 0.75 seconds, right? So the distance that the car travels before you hit the brake, you need to add that. Does it make sense? You got it, Janina? All right. So the distance that it traveled at constant constant velocity, not speed. Yeah, speed you can say also. So that one, you gotta find. So like this distance. I don't know how you can say like this is del x2, that this is del x1, you can say that way. So that del x1 you can find it by using this velocity multiplied time. Okay, now what velocity? This v0. What time? It depends. You have two scenario, right? You have scenario 1 when this time is 0.75 second. You have the other scenario when the time is what? 3 seconds. Is it clear to everyone? All right. If you understand so far what I just said, then obviously you gotta use the same equation what you just did before, right? The same one. Okay, because remember the previous one had a constant acceleration when the car was free fall, right? G was the acceleration. Here in this case, it is not in free fall. It's running. You're pressing the brake, but it's reducing the speed with some deceleration value, but it's constant. They didn't have for the A equation. They said this is 2 feet per second square. They didn't give like with a relationship of that acceleration, right? So it's a constant acceleration. Anytime you have a constant acceleration or constant deceleration, you can use the same equation like this one to find what to find. In this case, if you assume that one is free for y-axis, right? But in this case, if you assume it's x-axis, right? So then you just replace it with dx or x, whatever. Does it make sense? You understand what I'm saying? You use the same equation, right? Because you have this a is constant. Whenever you have this a is constant, is the a constant here? Because the g is constant, right? Understand? Is the a constant here in this problem? Yes. So use the same equation. What to find? To find this del x2. Does it make sense? Which is here for this problem. Everyone got it? Everyone got it?
Yes.
Does you got it?
Yeah.
Okay, perfect. Everyone got it?
Sure.
Can you do that? Any question? Okay. I'm not writing anything. I mean, I did talk about it. Yes.
What if there's no constant?
Huh?
What if there's no constant?
Oh, if this is not constant, then you should be doing the integration. Remember? Just like the way the nonlinear acceleration equations you had done in last class, remember? We had the equation with a equal s to the power something. Have you done it the time? You have to go? We probably have like 5-6 more minutes left, right? Is it? If you have to go, you can go. It's all right. It's fine. All right, the third problem. What is the third problem? Actually, 8 minutes left. I have plenty of time to deal with so many problems. Rolina, if you have to go, please have some cookies. You came a little late, okay? So, all right. So the third problem, let me read through that. Let me get my notes as well. So this one, this one is like Arlen's quotient came and play, right? You see, A has a relationship with T, so it's not a constant acceleration anymore, right? So it does have a relationship. So let me, I mean, without further reading everything, I'm giving you the whole detail. I'll try to give you an equation. Okay, so let me give you that V equation. So which is 0 to T, this A dt. Now, you know, this A has a relationship where A equal minus 6t. See? So you got to plug this A value here, do the derivation. What are you going to find? You're going to find the value of the velocity. So what is this to velocity that I put over here? So the first one is the final velocity, right? Everyone understand that? VEL, anytime you see me writing VEL means velocity, okay? Okay, and then this one is the initial velocity. Anytime you see a subscript 0 means initial, okay? The first one. That's the initial velocity. All right, and then once you solve this, what you'll be finding from here? You'll be finding time value, okay? So what they're asking, where t in second, determine the distance traveled. They didn't ask for the time, but you need to find the time to find the distance, right? So to find the distance, what are you going to do? You're going to do the integration again, okay? So you have this 0 to t, and then you have this v dt, okay? And then you can rewrite that as 0 to 3. And by the way, I'm giving you this answer 3 from here, okay, in case if you're wondering. So this 0 to 3 seconds, because time t, anytime you see me writing t means time, okay? So I'm giving you the first part result. When you're gonna do the integration, right? For the first part, you'll be finding the value of the time t equal to 3 seconds. That's the answer. Okay, and then you're gonna put it over there, obviously, and then you're gonna write this relationship, which is 27. Okay, see, in case if you're wondering, this V0 is 27, right? You see that? So you are writing this V relationship, and then you'll have this this part. When you're gonna put this minus 6t, you're gonna have something come up, which I'm giving you the final form, actually giving you answer technically, 3t square. Okay, and then you gotta do this integration, okay? And you're gonna find the result as value would be 54 meter. Is it clear? That's your final answer. That's number 3. I still have like 3-4 minutes left. I can deal with 1 or 2 more. It's good so far? So what you have to do in this one? See, you clearly need to know the integration and derivative knowledge here, okay? Whenever you have this nonlinear acceleration come in play, it's not straightforward, okay? Whenever you have a uniform acceleration, like on first 2 problems, you can simply use those equations directly, okay? But nonlinear, there's no equation. You gotta do the integration, okay? Because different case, different scenario. Okay, in this case, you have a scenario where the where the acceleration is a function of time. Okay, number 4. And number 5 is part of number 4. So if you're going to solve number 4, you should be done with number 5. But number 5, I'm giving you quickly the result that you'd be expecting. So your V is a, you see, MATLAB or Excel, you got to use that. Okay, MATLAB means like octave. Okay, so then you'll have this velocity, or Excel. I mean, not necessarily you need to know the programming, or octave. Okay, but when you're going to use this MATLAB or octave or Excel, you should be getting a velocity versus position curve, something similar to like this. So you'll have something similar to like this. I'm just trying to give you that's something you'd be expecting your final value somewhere around 2500 here, 0 here. That's the distance I'm talking, right? And then your value would be like a little bit more than 100 feet per second here. Okay, just to give you something that you'd be expecting. Okay, that's the number 5. Okay, you may want to take the notes, or the video recording will have this thing as well. But let me deal with number 4 then we'll be going 2 more minutes. That could be enough. All right, any question with this one? Number 5, number 4. Okay, so number 4, we have done a similar problem. Remember in last class we were given with like what acceleration? We were given with the acceleration. We will probably find the position, right? In last class, very similar problem. But still, first of all, you have to understand you got to solve this problem for these 2 different limits, right? In last class, you remember that there are 2 limits in last class, right? All right, so you have these 2 limits, so you can do this thing, acceleration. You have, for the first limit is 6 feet per second square, right? And that's for s value 0 to 1000 feet, and the second one is minus 4 feet per second square, and that's for the s value more than 1000 feet. Okay, and that goes until the s value become what? S prime. The middle s doesn't look like s, but that's s. Please, there's overriding, please ignore that. Okay, so then you have to find several things here. First of all, you got to find the stopping distance. Okay, so stopping distance, for the car stopping distance, you gotta do this equation where you know a equal v dv ds, and that's the derivation we did at the first thing that in the class, if you remember that. Okay, from there you can write this dv equal a ds, right? And from there you can write your v square. I mean, once you're going to do the integration, right, you're going to find v square equal v0 square plus 2 multiplied a ds. Now this a is a function of s, right, as you can see here. So you're going to plug this a value here, do the integration just like in last class. We did the similar thing in last class. Okay, just please review the last class note. Okay, we did the integration. All right, and then you see you do have these 2 different reasons, right? Reason 1, reason 2, reason 1 and reason 2. Okay, on those 2 different reasons, you're going to find this v2 value, right? You're going to find this v2 value, and then you're going to find this v1 value. Okay, and then you're going to use this. You're going to use this in position equation. Okay, so position equation would be v square equal so v2 square or v1 square. That's the way you can say 2 2 multiplied this acceleration, right, ds. So you're gonna use that when the v value is 0, then plug this v value here, and you should be able to find the s or distance. Okay, but again here you got to do some integration again, and the last portion that I have here, you got to plug that a as s and then do the integration, find the s value. Okay, again you got to plug the value v equal to 0. Okay, from the v1. Once you have the v1, then plug this v1 value and v2 as 0, and then find the value of the s. But again, you got to do the integration. Okay, so that one is the most challenging, I would say. Has some relationship with the last problem that we did in class. It's not like you are in the water. Okay, you have some direction now. You should be able to solve it. try to submit it in by Monday. Okay, so you can focus next week with homework number 2. There are like around 10 homeworks for this class. Okay, so we should be finishing up by after 2 weeks the first homework. So we are in good pace. Okay. There are so many cookies left. Did you know you didn't have cookie? Anybody else want to get some cookies? Please help yourself.
Right.
It's Friday. Have some sugar rush if you want to.
What's that?
Okay.